Hello students and good morning. So now I am doing class for class 12. The topic is the same topic that we were doing in the last online class, that is standard integrals. So today we will continue this chapter. Same exercise 6b, page number 363, 5 mark section from the book Higher Mathematics for class 12 by SND. So let's do this question number 11 now. And in the last online class we did question number 10. I hope you revise all the problems that we did so far. So let's do this question now, that is question number 11, that is integration of dx divided by within bracket 1 minus x within root over x. So we are doing such type of integration. What is the method here? So outside is square root, in the denominator there is 1 minus x, here the power of x is 1. And within the square root also, here the power of x is 1. So what was the method? So in the last online class we did two methods. So whenever you have integration of the form dx divided by ax plus b within the square root px plus q, that is the power of x, outside square root is 1 and inside square root also the power of x is 1. So whenever you have such type of expression, you have to assume z square as the expression, that is the expression on the square root should be assumed as z square. So here you can use the same method, that is dx upon 1 minus x within square root, x is there. So outside square root the power of highest power of x is 1 here, and within square root here also the power of the highest power of x is 1. So we have to assume the expression on the square root as z square. So let's do this problem now. So first of all, let us write here I is equal to integration of, this is dx divided by 1 minus x, and this is root over x. Okay, so what is the method for evaluating it? So we can assume, that is we can assume z square is equal to x, that is the expression on the square root should be assumed as z square. So let us write here, let z square is equal to x. Okay, that is the expression on the square root, that is x is assumed as z square. That is the method, that is the first method. Okay, so now let us write here differentiating both the sides, with respect to x. So what do we get? It is 2z into dz by dx is equal to 1, or now this is 2z dz is equal to, this is dx. Is that understood now? So now let us put these values in I. So therefore now I becomes, I is equal to integration of, what is this dx? What is the value for dx? It is 2z dz. It is 2z dz divided by within bracket 1 minus, what is x here? It is z square, bracket closed, and within square root this is z square. What is within square root z square? That is your z. So here z will be cancelled. So I think you have understood it. Okay, so now there is constant 2 in the numerator, you can take it outside integration. Therefore I is equal to 2 integration of, this is dz divided by what? It is 1 minus z square. Okay, so again 1 can be written as 1 square. So this is the standard form. This is standard integral number 3, that is integration of dx divided by a square minus x square. What is the formula? What is this integration? This is standard integral number 3, third standard integral, that is integration of dx divided by a square minus x square. So what is this integration now? It is 1 by 2a log within mod a plus x divided by a minus x, mod sign closed, the base is e, then plus c. Okay, so this formula can be used here. So instead of a there is 1, instead of x there is z. So this is the third standard integral. Or I is equal to 2 into 1 upon 2 into what is a 1, then log within mod it is a plus x. That is a plus x means 1 plus z divided by 1 minus z, mod sign closed, the base is e, then you have to write plus c. Okay, so here you can cancel these 2 will be cancelled. So or I is equal to, this is 1 upon 1, you don't have to write it, so it is log within mod 1 plus, what was z actually? Z is root over x, isn't it? If z square is equal to x, what is the value for z? Root x. So it is 1 plus root x divided by 1 minus root x. Mod sign closed, the base is e, then what do we write? Plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do next type of question, that is question number 12. You have to evaluate this integration. That is integral of root over x dx divided by x minus 1. So here root over x, within square root there is x which is in the numerator, and in the denominator we have only got x minus 1. So from here also you have to remove square root from the numerator, square root of x. So you have to remove square root from x. So we can assume here x is equal to z square. Okay. So before that, let us write I is equal to integration of, this is root over x dx divided by, this is your x minus 1. So what is the method in this case? You have to remove square root from x which is in the numerator. So let us put here, let x is equal to z square. So we are doing the method of substitution, that is we are putting x is equal to z square in order to remove square root from x. Okay, so let us differentiate it. So differentiating both the sides with respect to x, or you may write with respect to z also. So we are writing here with respect to x. So therefore this is dy dx of x is equal to, this is dy dx of z square. Is that clear? Next, what is dy dx of x? That is 1 which is equal to, what is dy dx of z square? It is 2z into dz by dx. Is that clear to all of you? So now you can do cross multiplication. So what is the value for dx now? Which is equal to, this is 2z dz. So dx is equal to 2z dz. Okay. So now next, let us put these values in I. So therefore what does I become now? So I is equal to integration of, within root x is there. What is x here? Z square. So it is root over z square into, next, what is the value for dx? It is 2z dz. Let us write here 2z dz, this whole divided by, what is x here? It is z square. Then you should write minus 1. So it is z square minus 1. Okay. So or I is equal to, which constant is taken outside? 2 is a constant in this case. It is taken outside. Integration of, what is root over z square? Z. Root over z square is z. Z into z is z square. So this is z square divided by z square minus 1 dz. Z square divided by z square minus 1 dz. So now what is the method in this case? So now in this case, the highest power of z in the numerator is 2, and also in the denominator the highest power of z is 2. That is the highest power of both. That is the highest power of z. The highest power of z in both the numerator and the denominator are same. So what is the method in this case? Whatever is there in the denominator, you write it in the numerator. Okay? So यहाँ माथि पनि z को हाईएस्ट पावर 2 छ, तल पनि z को हाईएस्ट पावर 2 छ, that is same छ भने तलको j छ हामी माथि त्यही लेख्छौं. That is the method, isn't it? So or I is equal to 2 integration of, this is z square minus 1. Let us put it within bracket. So z square is correct, but we are getting minus 1 here. But is there minus 1? No, you have to cancel it. So you should write plus 1 divided by, this is z square minus 1. Then what do we write? dz. Is that clear? So let us separate this fraction as well as integral sign and dz also. Okay? So let us separate this fraction as well as integral sign and dz also. So this is 2 integral sign, z square minus 1 divided by z square minus 1 will be cancelled. You will get only dz. Then plus sign is there. Okay? Now 2 is multiplied by 1. That is 2 ones are 2. So 2 is constant. It is taken outside. Integration of, that is 1 into dz is dz divided by what? It is z square minus 1 can be written as 1 whole square. 1 can be written as 1 whole square because this is the standard form. So which standard form is this one? That is second standard form. Integral sign dx divided by x square minus a square. Here instead of x there is z, instead of a there is 1. So there is a formula, isn't it? So or now it is I is equal to 2z, integral sign dz is z, plus 2 is constant, you have to write it. Now you have to write down the formula. This is in the form integral sign dx divided by x square minus a square. That is your second standard integration. So what is the formula for second standard integration? Instead of x there is z, instead of a there is 1. What is the formula? 1 by twice a log within mod x minus a upon x plus a. The base is e, then you have to write plus c. Now let us write down the formula. This is 1 by 2 into, what is a? 1 log within mod, what is x minus a? Z minus 1 divided by z plus 1, mod sign close, the base is e, then what do we write? Plus c. Is that clear? So now here you can cancel these, 2 will be cancelled, or I is equal to 2 into, what is the value for z? What is z in this case? Since z square is equal to x, what is the value for z? Root x. So here we can write root x plus, this is 1 by 1 is 1. So it is log, the base is e within mod, what is z? It is root x minus 1 divided by root over x plus 1, mod sign closed, base e, then plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 13. So you have to evaluate this integration. The question is integration of dx divided by x root over 2ax minus a square. So here the variable is x. So you have to see the power of x. You have to consider the power of x. So outside square root there is x. Here the power of x is 1. This is linear expression in x. And within square root also we have to consider the term containing the variable, that is x. Here also the power of x is 1. So there are two methods. I already told you about the two methods. One is you have to assume the expression on the square root as z square. And the other method was the expression outside the square root can be assumed as 1 upon z. I told you about that. two type of integration, isn't it? So this is the first type of integration. So here outside square root there is x, and the power of x is 1 here, and within square root also the power of x is 1. So what is the method in this case? You have to assume the expression under square root as z square. Is that clear? So let us first write down, therefore I is equal to integration of, this is dx divided by x, this is root over 2ax minus a square. So in this case both the power of x is 1. That is linear expression in x. So you have to assume the expression on the square root as z square. Okay. So let z square is equal to 2ax minus a square. That is, expression on the square root is assumed as z square. Okay. So you can differentiate it now. So this is the method of substitution. So in case of integration by the method of substitution, so if you assume 2ax minus a square as z square, again you have to differentiate it both the sides with respect to x, because we have to get the value for dx also. Okay. So differentiating both the sides with respect to x. Okay. So, or what is the differentiation of z square with respect to x? It is 2z into dz by dx is equal to, what is there on the right hand side? What is the differentiation of 2ax with respect to x? 2a is constant, and what is d by dx of x? That is your 1. And what's about this a square? A square is constant. What is the differentiation of constant with respect to x? That is always 0. So 0, you don't have to write it. Okay. So in this case you can cancel these two. Now cross multiply, or z dz is equal to, this is a dx. Is that clear now? So now let us get the value for dx, which is in the numerator. What is the value for dx? So a is taken to the left hand side, so z dz divided by a. So when a goes to the left hand side, you should write it in the denominator, which is equal to, this is your dx. Is it clear now? So this is the value for dx, right? So now let us put these values in I. Therefore I is equal to, this is your integration of, what is dx? Dx is z dz divided by a upon. Now in the denominator there is x only. So you have to express this x in terms of z. So get the value for x from this equation. Okay. So what is the value for 2ax now? It will be z square plus a square is equal to 2ax. Right. And what is the value for x from here? X is equal to z square plus a square divided by 2a. Is that clear? So what is the value for x from here? First of all, minus a square is taken to the left hand side. So it is z square plus a square is 2ax. And what is the value for x from here? 2a is taken to the left hand side. So it is z square plus a square whole divided by twice a. That is the value for x. So let us put it out here. Okay. So what is the value for x in this case? This is z square plus a square divided by 2a, bracket closed. Okay. Then this is root over z square, isn't it? 2ax minus a square is z square. So what is root over z square? That is your z. So here you can cancel, this z will be cancelled and this a will be cancelled. Okay. So next, or I is equal to, now in this case this 2 is constant, which is in the denominator, so it goes up in the numerator. So here 2 is a constant quantity, so 2 is taken outside, integral sign, it is integration of dz divided by z square plus a square. Now you know that this is the standard integral. Instead of x there is z, instead of a there is a. So this is the first standard integral, that is integration of dx divided by x square plus a square, which is equal to, what is the formula? This is the first standard integral, isn't it? So which is equal to 1 upon a, this is tan inverse, this is x upon a plus c. So we can use the formula in this case. So or I is equal to 2 is constant, you have to write it. Now write down the formula. Instead of x there is z. Instead of x here it is z. Instead of a there is a. So what is the formula? 1 upon a, this is 1 upon a, then tan inverse, that is z upon a. X upon a means here z upon a plus c. Now you have to put the value for z. What is z actually? It is root over 2ax minus a square. Or now it is I is equal to 2 upon a. This is your tan inverse within bracket. What is z? Z square is equal to 2x minus a square. What is z is equal to root over? It is root over 2ax minus a square divided by a. Then what do we write here? Bracket closed. Then you have to write plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next problem. Okay. So now we'll do the next type of question, that is question number 14. You have to evaluate this integral, that is integration of dx divided by x root under x square minus a square. Now this is now you have to use the different type of method, that is in this case outside square root there is x which is in the denominator. Here the power of x is 1, but within square root the power of x is 2, that is your quadratic expression. So in this case we will use different method of integration. Okay, so I told you about these two type of integration, isn't it? In the last online class I told you about these two type of integration, that is integration of dx divided by this was your px plus q and root over ax plus b. So if you have such type of integration, that is here both the power of x is 1, that is a linear expression. Here you have to put, or you can assume z square is equal to ax plus b. So I told you about this method, isn't it? And there was second type of integration, that is number 2, integration of dx divided by this is px plus q into px plus q into, then within square root, there is ax square plus bx plus c. Now in this case in the denominator outside square root there is px plus q, and here the power of x is 1, and within square root what is the highest power of x? There is 2, and there is term containing x to the power 1 also, that is your quadratic expression in x. So whenever you have such type of integration, so what is the method for integrating it? You always put px plus q is equal to 1 upon z. Is it clear now? So we can assume the expression, that is linear expression, that is px plus q as 1 upon z. Okay, so we have done this first type of integration. I've shown you some examples regarding first method of integration, isn't it? Now let us use this second type of integration. So now this is question number 14. Let us compare this 14 number and this method 2. So integral sign dx divided by x, instead of px plus q there is x, and root over x square minus a square is there, and instead of x square plus bx plus c there is x square minus a square. So we can use this method number 2. Okay, that is px plus q. In this case in method 2 px plus q was assumed as 1 upon z. Now in this case we have to assume x is equal to 1 upon z. Okay, so let us first write here I is equal to integration of this is dx divided by x root over this is x square minus a square. Now in this case the power of x is 1, which is outside square root, and within square root the power of x here is 2. So we have to use this method number 2. So we can assume x is equal to 1 upon z. That is, this linear expression in x can be assumed as 1 upon z. So let x is equal to 1 upon z. Okay. So now let us differentiate both the sides with respect to z. So differentiating both the sides with respect to z. So this is dx by dz is equal to, I told you that you can directly integrate this function. What is the differentiation of 1 upon x with respect to x? I told you about that in differentiation, isn't it? What is the differentiation of 1 upon x with respect to x? Directly minus 1 upon x square. Similarly here it is minus 1 upon z square because it is differentiated with respect to z. Okay. Now get the value for dx. What is the value for dx in this case? It is minus dz divided by z square. So we have got the value for dx. Okay. So let us put these values in I. So therefore I is equal to, so now it is integration of what is dx? Minus dz upon z square divided by, in the denominator what is x? 1 by z. It is 1 by z. Then within square root, what is x square? It is 1 by z whole square. That is 1 upon z square minus, then a square is kept as it is. That is your a square. Is that clear? So here you can cancel this z and square will be cancelled. So now you can take only minus sign. You can take only minus sign outside. So or I is equal to minus sign is taken outside. So it is integration of, in the numerator we have dz upon z. dz upon z divided by, this z is cancelled. So within square root, what's the LCM? Within square root, what is the LCM? It is z square. Within square root, z square is the LCM, isn't it? So this will be 1 minus a square z square. So I think you have understood it. So let us simplify it. Or I is equal to minus integration of, this is dz upon z divided by, in the denominator, this z square upon z square can be taken outside square root. That is 1 upon z within square root 1 minus, this is your a square z square. Okay. So now again this z will be cancelled. So or I is equal to minus integration of, this is dz divided by within square root, we have here 1 minus a square z square. Is that clear now? So now how will you integrate it? So how can you integrate this function now? So now you have to convert it into standard integral form. You know standard integral, isn't it? That is integration of dx divided by root over a square minus x square. So you have to make the coefficient of z square 1 here. So you take a square common. So or I is equal to minus integration of, this is dz divided by within square root. What is common out here? A square is taken common. So within bracket we have 1 upon a square minus z square. Is that clear? So within square root here a square is taken common in order to make the coefficient of z square 1. So it is 1 upon a square minus z square. So what is square root of this a square? That is 1 upon a, it is taken outside. I is equal to minus 1 upon a integration of, this is dz divided by within square root. It is it can be written as 1 by a whole square minus z square. So I think you have understood it. Okay. So now let's use the formula. Now you know that this is the sixth standard form. What is the sixth standard form here in this case? Integration of dx divided by root over a square minus x square. Instead of a there is 1 upon a. Instead of x there is z. So what is integration of dx divided by root over a square minus x square? That is sine inverse x upon a. Here x is z and what is a? 1 upon a. So let us write here, or I is equal to, this is minus 1 upon a. Then you have to write sine inverse x by a. What is x? Z divided by what is a? 1 upon a. It is 1 upon a bracket closed plus c. Right? So now you can put the value for z, or I is equal to minus 1 by a, that is constant, it is kept as it is. Then sine inverse, what is z? Actually what was z? That is x is equal to 1 upon z. So from here, what is the value for z? It is 1 upon x. So let us put the value out there. What is z? It is 1 upon x. It is 1 upon x divided by 1 by a bracket closed plus c. So let us simplify it, or I is equal to minus 1 upon a. This is your sine inverse, within bracket a goes up in the numerator, a upon x bracket closed plus c. So this is the final answer. So I think you have understood it. So now we will do this type of problem, that is we have to use this method number 2. Okay. So in the denominator outside the square root, the power of x is 1, that is your linear expression, and on the square root the hash power of x is 2, that is the quadratic expression in x. So in this case we can use the method px plus q is equal to 1 upon z. So now we'll do this type of problem, that is method number 2. Okay. So I think you have understood it. So you can copy it. Now we will do the next question. So now we'll do next type of question, that is you have to evaluate this integral. That is integration of dx divided by 1 plus x root under 1 plus 2x minus x square is there. Okay. So now in this case, so I think this is wrong question. So actually 1 plus x, it is root over, actually this was wrong. It is dx divided by 1 plus x, then within square root 1 minus x square. Then we have here within square root 1 minus x square. Okay. So now this is 15 number 1. Integral sign dx divided by 1 plus x into root over 1 minus x square. This is the correct question. Okay. So let's do this question number 15 number 1. So you have to evaluate this integration. Integral of dx divided by 1 plus x root over 1 minus x square. Okay. So outside square root there is expression 1 plus x. Here the power of x is 1, which is the linear expression in x. Okay. And within square root there is hash power of x is 2. That is the quadratic expression in x. So what is the method for integrating it? So let us first write, therefore I is equal to integration of, this is dx divided by 1 plus x, and this is root over 1 minus x square. So this is the second type of method. This is, you have to use the second type of method in this case. That is, we can assume that is 1 plus x, which is linear expression in x. We can assume this expression 1 plus x as 1 upon z. Okay. So let 1 plus x is equal to 1 upon z. So what will you do now? Differentiating both the sides. Differentiating both the sides with respect to z. Okay. So therefore, what is the differentiation of 1 with respect to z? That is 0. What is the differentiation of 1 with respect to z? That is 0, because this is constant. What is the differentiation of x with respect to z? That is dx by dz is equal to minus 1 upon z square. Is that clear? So directly we can write down the differentiation of 1 by z with respect to z, which is minus 1 upon z square. Okay. So what is the value for dx now? So dx is equal to minus dz upon z square. So I think you have understood it. Okay. So let us put these values in I. So I is equal to integration of, what is dx? It is minus dz upon z square. And in the denominator, what is 1 plus x? It is 1 by z. It is 1 by z. Then within a square root, there is 1. Let us write 1 minus, but we have got x square here. So you have to get the value for x from here. What is the value for x from here? So x is equal to 1 upon z. This 1 is taken to the right hand side. So it becomes minus 1. Okay. So 1 minus, let us put the value for x. What is x? 1 upon z minus 1 whole square. Is that clear? So here you can cancel this, z and square will be cancelled. So or I is equal to minus sign is taken outside. This minus sign is taken outside. Integral sign, this is dz upon z. Is that clear? dz by z. Now within a square root in the denominator, you have to simplify it. So let us simplify it. This is your, there is 1. You have to write 1 minus. Let us write 1 minus. Now since this is a minus b whole square. What is a minus b whole square? A square minus twice ab plus b whole square. So let us write here within bracket, what is a whole square? 1 upon z whole square. That is 1 upon z square. Right? Then minus twice ab. What is minus twice ab? Minus 2 into a is 1 upon z into b is 1. Plus b whole square. Plus, what is b whole square? 1 whole square. That is your 1. Plus 1. Bracket closed. So I think you have understood it. Now let us simplify the expression on the square root. So or I is equal to minus integration of, this is dz upon z divided by within a square root. Let us simplify it. 1 minus 1 by z square, minus into minus, plus it is 2 by z, then plus into minus, minus 1. So here this 1 and 1 will be cancelled. So or I is equal to minus integration of, this is dz upon z divided by within a square root. What's the LCM here now? It is z square. Z square is the LCM, isn't it? Z square and z, what is the LCM? Z square. So in the numerator it becomes, this is minus 1 plus, and now z square is divided by z. So it is z. Z into 2 is 2z. Right? So or I is equal to minus integral sign, this is dz by z divided by, what is root over upon z square? It is 1 upon z, and root over, this is 2z minus 1. So here you can cancel this z. Let us cancel it. Okay. This z and z will be cancelled. Or I is equal to minus, or I is equal to, this is minus sign, integral sign. This is dz upon, write down the remaining terms. So it is root over. It is root over 2z minus 1. This is your 2z minus 1. Okay. So now you have to evaluate that integral. That is minus integral sign dz upon within square root 2z minus 1 is there. But this is not the standard form. Why is it not the standard form? Because in this case the power of z is 1. So this is not a standard form. So within square root, if the power of z is a square, then we could have converted into a standard integral. Then accordingly we can evaluate this integration. Okay, but here the power of z is 1, so this is not the standard integral. You can directly integrate it. So since here the power of z is 1, this 2z minus 1 can be taken as z. Okay? So it is root over z. Root over z means z to the power half. Then it is taken to the numerator to make it z to the power minus half. Right? So or now it can be written as I is equal to minus integral sine dz divided by, let us write it as 2z minus 1 whole to the power half. Okay? Now it is taken to the numerator, or I is equal to minus integration of, this is 2z minus 1 whole to the power minus half, then it is dz. Now this is just like your x to the power n form or z to the power n, because within whole to the power minus half the power of z is 1 in this case, that is 2z minus 1 is there. This 2z minus 1 can be taken as z. So it is in the form z to the power n. So what is the integration of z to the power n? It is z to the power n plus 1 divided by n plus 1. Okay? So or I is equal to minus, what is z here? 2z minus 1. So let us write 2z minus 1 whole to the power n plus 1. What is n plus 1? Minus half plus 1 divided by n plus 1. That is minus half plus 1. Let us keep it within bracket. But in this case, which function was taken as z to integrate it? 2z minus 1. That function is to be differentiated. Okay? The function which is assumed as z is also to be differentiated. So what is the differentiation of 2z minus 1 with respect to z? It is 2 only. For z is 2z is there. 2 into d by dz of z is 1. 2 into d by dz of z is 1. 2 into d by dz of z is 1. So it is 2 minus, for 1 it is constant, this differentiation is 0. So it is only 2. But in case of differentiation you have to multiply it by 2. But this is the case of integration. So you have to divide it by 2. That is, you have to divide the expression by the differentiation of the function which is taken as z. Okay? So into, what do we write here? Into 2. That is in the denominator, not in the numerator. The numerator ma हामी लेख्छौं कति बेला differentiation मा हो भने मात्रै. तर integration मा हुन्छ dividing by differentiation of 2z minus 1, that is 2. Then what do we write here? Then you have to write plus c. So I think you have understood it. So or now this is I is equal to minus, so now this is 2z minus 1 whole to the power minus half plus 1 is half, divided by minus half plus 1 is half, into 2, then we write plus c. Here 2 gets cancels. Is that clear? So let us put the value for z now. So I is equal to minus, now you know that whole to the power half means square root. Whole to the power half भनेको नै square root हो, you know that. Whole to the power half means that is your square root. So let us write it within square root. 2 into, what is z now? What is z from here? If 1 plus x is equal to 1 upon z, what is the value for z from here? It is 1 upon 1 plus x. Is that understood? If 1 plus x is equal to 1 upon z, so what is z is equal to 1 upon 1 plus x? So it is 1 upon, this is 1 upon 1 plus x, then minus 1 plus c. Is that clear? So let's simplify it. Or I is equal to minus, within square root, what's the LCM? 1 plus x. What is there in the numerator? It is 2 minus 1 minus x plus c. Or I is equal to minus, within square root, in the numerator 2 minus 1 is 1. 1 minus x divided by 1 plus x. Is that clear? Then what do you write? Plus c. So this is the final answer. So I think you have understood it. Okay, so you can copy it. So this question is very, very important, so you can mark it. Okay, so you can copy this. Now we'll do the next question. So now we'll do the next question, that is 15 number 2. You have to evaluate this integration. That is integration of 2x dx divided by, in the denominator there is expression 1 minus x square which is outside square root, and within square root there is x to the power 4 minus 1. Okay, so let us write here first I is equal to, so I is equal to integration of 2x dx divided by 1 minus x square root over x to the power 4 minus 1. So now in this case, first of all, you have to use the method of substitution. Now in the numerator we have 2x. Now differentiation of which function is 2x x square, isn't it? And there is x square here. This x to the power 4 can be written in terms of x square whole square. Then we can do the method of substitution. Let us assume x square is equal to z. Okay, so therefore I is equal to integration of, this is 2x dx divided by 1 minus x square. So this is root over x square whole square, then minus 1. Okay, so what will you do now? Let z is equal to x square, because the differentiation of x square is what? 2x. So let z is equal to x square. So let us write here differentiating both the sides with respect to x. So what do we get? dz by dx is equal to, this is 2x. Now let us cross multiply it. 2z is equal to what? It is 2x dx. So I think you have understood it. So let us put these values in I. So therefore I is equal to integration of, what is 2x dx? It is dz divided by 1 minus z, isn't it? X square is z, right? So it is 1 minus z, and within a square root what do we have? What is x square? It is z square. Is that clear? So it is z square minus 1. So this is z square minus 1. So again you have to do the method of substitution in this case. Now both the expression are on the square root, and in the numerator we have dz. But outside the square root there is 1 minus z. Here the power of z is 1. That is your linear expression in z. And within the square root there is z square minus 1. Here the highest power of z is 2. That is the quadratic expression in z. Okay. So what is the method for integrating it? So this is the second type of integration. We have to use the second method of integration. Let us assume 1 minus z as 1 upon y here. The 1 minus z is already there. We cannot assume 1 minus z as 1 upon z. So let us assume different variable. Let 1 minus z is equal to 1 upon y. So let us write here, let, what is the method here? 1 minus z. That is the expression, the expression outside the square root. The expression outside the square root, that is linear expression in z. That is 1 minus z is assumed as 1 upon y. Is assumed as what? 1 upon y. So let us differentiate both the sides with respect to y. So differentiating both the sides with respect to y. So for 1 it is 0 minus dz by dy is equal to minus 1 by y square. So from both the sides you can cancel this minus. So what is the value for dz only? What is dz only? It is dy upon y square. Is that clear to all of you? So I think you have understood it. Okay. So let us put it in I. So therefore I is equal to integration of, what is dz? It is dy by y square. You write dy by y square upon, what is 1 minus z? It is 1 by y. Now within a square root now, there is z square. You have to put the value for z only. So we can get the value for z from here. What is the value for z? Can you tell me what is z here? 1 minus 1 upon y is equal to z. Now this z is taken to the right hand side, 1 upon y is taken to the left hand side. So it is 1 minus 1 upon y is equal to z. Is that clear? So now put the value for z here. What is z whole square? 1 minus 1 upon y whole square. Then what do we write? Minus 1. So I think you have understood it. Okay. So here you can cancel this y and square will be cancelled. Or I is equal to integration of this is dy by y. Right? Whole divided by this is cancelled. Now within a square root, let us simplify it. So now this is a minus b whole square. What is the formula? What is a whole square? 1 whole square is 1 minus 2 into a is 1, b is 1 upon y plus. What is b whole square? 1 upon y square, then it is minus 1. So here this plus 1 minus 1 will be cancelled. Is that clear? So let us simplify it further. Or I is equal to, now this is integration of, this is your dy by y divided by, right? Integration of this is dy by y, it is written there. So within a square root you can take the LCM. Within a square root, what's the LCM out here? For y and y square, the LCM is y square, right? So in the numerator, what do we write? This LCM is divided by y. Y square is divided by y. So it is y. So minus 2y. So y is multiplied by minus 2. That is minus 2y. Right? Then plus sign is there. Plus sign is there. Now this LCM y square is divided by this denominator. This LCM y square is divided by this denominator y square. So it is 1 time. So 1 ones are 1. So it is 1 ones are 1. Okay, so let us simplify it further. Or I is equal to integration of this is dy by y upon this is upon y square. It can be taken outside, 1 upon y. Then within square root, let us write positive term first, 1 minus, then we should write 2y. Okay, so here y gets cancelled. But this is not the standard form, because in this case the power of y is 1. So we can directly integrate it. Integration of this is dy divided by this is 1 minus 2y whole to the power half. Okay. So now this is not your standard integral, because within whole to the power half, the power of y here is 1. You can directly integrate it. 1 minus 2y can be taken as y to integrate it. So let us take it to the numerator. So or I is equal to integration of 1 minus 2y whole to the power minus half, then dy. It is in the form y to the power n or x to the power n. Okay, 1 minus 2y can be taken as x to the power n. So what is this integration? It is 1 minus 2y whole to the power n plus 1 minus half plus 1 divided by minus half plus 1. Right? Again, which function was taken as y? 1 minus 2y was taken as y. That function is also to be differentiated. What is the differentiation of 1 minus 2y with respect to y? For 1 it is 0 and minus 2y, and for minus 2y it is minus 2. Is that clear? For minus 2y it is minus 2. But in case of differentiation you have to multiply it by minus 2. But this is the case of integration, you have to divide it by minus 2. So you have to write down minus 2 in the denominator. Is that clear? Then what do we write? Plus c. So let us simplify it further. Or this is I is equal to, now this is 1 minus 2y whole to the power minus half plus 1 is half divided by this is minus half plus 1 is half into minus 2. So your 2 gets cancels, it is plus c. Right? So next, or I is equal to minus sign is taken outside, this minus is taken out, minus sign is taken outside, whole to the power half means root over it is 1 minus 2y then plus c. Is that clear to all of you? So I think you have understood it. Now you have to put the value for y. So let us put the value for y here in this case. So let us put the value for y now. So what is y actually? What was y actually? Since 1 minus z is equal to 1 upon y. Okay. So what is the value for y? It is 1 upon 1 minus z. Since 1 minus z is equal to 1 upon y. So what is the value for y? It is 1 upon 1 minus z. Or I is equal to minus root over 1 minus 2 into y. What is y? 1 upon 1 minus z. 1 upon 1 minus z. Is that clear? Then what do we write? Plus c. Or I is equal to minus within square root. What's the LCM? 1 minus z. So in the numerator we have, this is 1 minus z into 1 is 1 minus z, then minus 2 plus c, right? Or I is equal to minus within square root. Here we have minus z, 1 minus 2 minus 1. In the denominator also you take minus common within bracket. This is z minus 1 plus c. Is that clear? From the denominator you take minus common here. So within bracket what do we have? Z minus 1. So that we can get minus common in the numerator also. Minus within square root. Minus is taken common. So it is z plus 1 divided by minus is common here. Z minus 1. It is z plus 1. There is z minus 1. So it is plus c. So here minus minus gets cancelled. Now put the value of z. You have to express it in terms of x square. So in the beginning we had assumed this x square as z, isn't it? That was z is equal to x square. That's why it was differentiated and we got the value for 2x dx as dz. That was z is equal to x square. So we can put here, or I is equal to minus within square root. This z was x square plus 1 divided by this z was x square minus 1 plus c. So this is the final answer. So I think you have understood it. Okay, so you can copy it. This question is also very, very important. You can mark it. So now in this case, we have put the value for y from this case. Since 1 minus z is equal to 1 upon y. So what is the value for y? 1 upon 1 minus z. So instead of y, it is put 1 upon 1 minus z. So it is simplified. LCM 1 minus z minus 2. Minus z minus 1. From here minus is taken common, and in the numerator also minus is taken common. It is minus common, z plus 1, so minus minus gets cancelled. Now you put the value for z. So before we evaluate this integration, we had assumed this x square as z. That means z is equal to x square plus 1 divided by x square minus 1 plus c. So this is the final answer. That is I is equal to minus within square root x square plus 1 divided by x square minus 1 plus c. So that is the final answer. So this question is very, very important. You can mark it. So I think you have understood it. So you can copy it. Now this one is for today. So today also we did some problem. So all of you revise it at home. So if you have any difficulties or if you don't understand anything, you can call me. Or you can comment me also. You can write down the comments in the comment box. Okay. So if you have any problem, you can call me, right? Or you may write it in the comment box. So this much is for today. So in the next online class, we will do more such type of problems in the chapter standard integrals. So this much is for today.